Hello friends, in the last video we discussed about Z parameters. Now in this video we'll go to see what is Y parameters. Okay, Y parameters is nothing but admittance parameters. We know admittance is the reciprocal of impedance. In Z parameters we discussed about impedance, that is nothing but the Z parameters are the impedance parameters. Because why we call Z parameters or impedance parameters means in Z parameters describes the impedance of the two-port network, whereas Y parameter describes the admittance of the two-port network. Okay, let's see here. Y parameters are also known as admittance parameters. These parameters used to describe the electrical behavior of linear network. Here we have network. Okay, these Z parameters, Y parameters or all other circuit parameters are applied on the two-port network. Two-port network is nothing but, see here, it having two ports. Suppose assume it's an input port and it is the output port. I named it as the 1, 2 and 1 dash, 2 dash. Okay, let's see. In this two-port network, we have to apply two voltage sources and two currents. Those are input voltage as V1 and output voltage as V2. Input current flowing through this branch is I1 and output current I2. Okay, this is about not a impedance in two-port network. Okay, we already discussed about Z parameters. This is the reciprocal of Z parameters. Let's see the parameters equations. That is I1 is equal to Y11 V1 plus Y12 V2. Okay, next I2 equal to Y21 V1 plus Y22 V2. Here Y11, Y12, Y21, Y22 are the impedances of the circuit. Y11, here 11 indicates that is the in the input port. Y22, 22 indicates that is in the output port. Okay, and Y21, Y22, Y21 and Y12 are in between the input and output ports. Okay, I think you have understand. Suppose here observe these equations. Assume if our input voltage V1 is 0. If our input voltage V1 is 0. Substitute in equation number 1. Consider this is equation number 1 and this is equation number 2. If V1 equal to 0, the entire term will become 0 and the equation number 1 becomes as I1 equal to Y1 to V2. Now V2 equal to I1 by Y12. Okay, from this equation we have V2 equal to I1 by Y12. Okay, from this equation we can get Y12 equal to I1 by V2. Observe this, I by V, we know resistance equal to V by I and admittance equal to I by V. Here Y12 equal to I1 by V2. I1 is nothing but the input current, V2 is the output voltage. That is, it consists of both input parameter and output parameter, input current parameter, output voltage parameter. That's why it is in between the both input and output. I already told you Y12 and Y21 are the admittances in between the both input and output voltage. That's why here we have both input and output parameters. Next, consider equation number 2. If V1 equal to 0, then our equation number 2 will become as I2 equal to, this entire term will become 0, then Y22 V2. Y22 is equal to I2 by V2. Consider here, I already told you Y22 means impedance of the second port. Second port means output impedance. Here output, sorry, not impedance, admittance. output admittance y22 is equal to I2 by V2. Here 2 indicates these two are belongs to output side. That's why the impedance also known as output impedance. Next, consider V2 equal to 0. Assume V2, that is output voltage, equal to 0. Then substitute V2 value in equation number 1. Then equation number 1 becomes as, if V2 equal to 0, this entire term will become 0. Then we get only I1 is equal to Y11 V1. I1 equal to Y11 V1. From this equation, Y11 equal to I1 by V1. Consider this term here, y11 equal to I1 by V1. I already told you y11 is nothing but admittance of the first port, admittance of the input port. Okay, that's why it consists of both current and voltage are the input currents and input voltages, because it is the admittance of the input port. If suppose it is the admittance of the output port, then both currents and voltages are the output circuitry. Okay, both currents and voltages are belongs to the output circuitry, but here we have input impedance, not impedance, admittance. That's why we have input currents and input voltages. Next, substitute V2 equal to 0 in equation number 2. Assume, okay, not a 0, so simply assume for our calculation purpose. Then this entire term will become 0. When V2 equal to 0 in equation number 2, then this entire term will become 0. Then the second equation will become as I2 equal to Y21 V1. Y21 V1. Because this V2 equal to 0, the entire term will become 0. Then we get this equation like this. Okay. From this, Y21 equal to I2 by V1. Consider this is Y21. 21 is nothing but it is in between the second port and the first port. That's why here the currents and voltage also belongs to both first and second ports. Here I2 is nothing but second port current, that is output current. V1 is nothing but first port current, that is input port, not a current, input port voltage. This is how the admittance parameters are calculated by using two-port network. Okay, let's have one more simple method for calculating the admittance parameters in a two-port network. Simply first find the Z parameters. Z parameters we know Z11, Z12, Z21 and Z22. First find the Z parameters, then we know impedance is the reciprocal of admittance. Then simply apply inverse to the Z parameters, then we get Y parameters are Y11, Y12, Y21, Y22. Okay, this is how to find the admittance parameters for the two-port network. You can follow in this way also, or simply find the Z parameters and apply inverse to get Y parameters. This is about Y parameters. Thank you for watching this video.